All right, we have two things that we're going to talk about today. We are going to talk about the intermediate value theorem, and we are going to use a calculator to analyze polynomials, which is why I'm doing notes where you can see my hands so you can see my calculator. All right, now this first part, which when or if you take calculus next year, you will see IVTs again. We even have a nice little IVT poster right up here for AP Calculus that you can refer to. So what the intermediate value theorem proves is it proves a point. So what it says is that if your function is continuous, so there's no jumps, there's no holes, there's no vertical asymptotes. So we have a continuous function, and your endpoints are not the same thing. So f of a, which is right here, and f of b, which is right here. All right, they're not the same. Then there is a number k, so k is right here, between f of a and f of b. All right, so it proves a point. It proves a point is in between your two endpoints, which is kind of obvious. So if you have this point here and you have this point here and your line is continuous, then all of these points in between exist. Does that make sense?
Yes.
All right. The way I like to think about intermediate value theorem is it proves the points in between. Intermediate in between. Those kind of sound similar. That's how I have it memorized. Now, IVT is an existence theorem, which means all it does is it say it's there. It doesn't give us any way to find it without more information. So all IVT can do is be like, yeah, that point exists. I don't know what it is, but I know it's there somewhere. Bless you. All right. So on this first one, it says, would you be able to use IVT for the function h of x equals 1 over x minus 2 on the interval from 1 to 3, why or why not? So the first thing we're going to check for is continuity, because that's the first thing that you has to be true for you to use IVT. All right. On this one, are you going to jump? No, the only time that you're going to jump is if you have a piecewise. All right, does it have a hole? Holes have to have common factors on top and bottom, so does this one have a hole? Nope, because there's not the exact same thing on top and bottom. Does it have a vertical asymptote? Yes. So we are going to take the bottom and we're going to equal it to 0. And we're going to add 2 on both sides. And so you have a vertical asymptote at x equals 2. Now, is that point in my interval? Is 2 between 1 and 3? Yes. Yes. So is this graph continuous on my interval from 1 to 3? No. So will IVT work? No. So we're going to say no, because h of x is not continuous from 1 to 3.
Is it because the vertical asymptote goes through it?
Mm-hmm. So 2 is on that interval, right? From 2 hits from 1 to 3. So because there's a vertical asymptote, you're not continuous on the interval, so you can't use IVT.
So there's almost a gap.
Mm-hmm. Yes, exactly.
What is 1, 3? Like,
What is what?
Is that like a line?
Vertical asymptote?
Oh, so 1 to 3 is an interval. Shh, quit talking. So this is x1, this is x2. So when you're talking about your graph, we're talking about the points from 1 to 3. So we're only talking about this part of my graph. So that part of the graph, that little section from 1 to 3, has to be continuous for you to use IVT.
Okay.
Yeah. I still hear whispering. All right, use IVT to show that f of x equals x cubed plus 2x minus 1, and it has a 0 on the interval from 0 to 1. So we're going to use the intermediate value theorem to prove 0 exists. So this is what we're trying to prove exists. All right, so the first thing we need to show is that it's continuous. Is x cubed plus 2x minus 1 continuous? Does it have any jumps? Is it a piecewise? Nope. Does it have common factors on top and bottom? Is it there a hole? Nope. And is there a factor in the bottom that's going to give you a vertical asymptote? No. So that's why, remember when we checked for all those discontinuity points? This is why, so we can decide if a function is continuous or not. So on this one, there's no jumps, there's no holes, there's no vertical asymptotes. So it is continuous. So first thing we're going to say is that f of x is continuous. All right, the next thing we have to prove is that 0 exists. So we need to figure out our y values. So this is x1, this is x2, because it's talking about an interval. So 0 and 1 are x's, and we have to figure out our y values of these x's to see if 0 is between them. All right, so when I plug 0 into my function, when I plug 0 into here, what's 0 cubed? 0. Plus 2 times 0? Minus 1? Negative 1. All right, so f of 0 is negative 1. When I plug 1 in, what's 1 cubed? 1. What's 2 times 1? 2. What's 1 plus 2? And then minus 1? 2. All right, so those are my y values. All right, so I've got my y value at negative 1, and I've got my y value at 2. Is 0 going to be in between those 2 points? Yes. So essentially what's happening is I'm hitting 0, negative 1, and I'm hitting 1, 2. And I don't know what my function does, but I know it's continuous, so it's got to connect. There's no holes, there's no jumps, there's no vertical asymptotes. So is there any way that you could draw a line between these 2 points and not hit 0? No, you have to hit 0. If you're going to go from here to here, you have to hit 0. And so that's what IVT proves, is that 0 does exist. So the way that we're going to write this last part here is we're going to say negative 1 is less than 0 is less than 2. So yes, f of x has a 0. From 0 to 1. You do not have to write this using this math notation, like negative 1 is less than 0 is less than 2. You can actually say in words, you can say 0 is between negative 1 and 2 if you don't like this statement, but that statement is shorter than writing that sentence. So you either need to state it in words or state it using math. One of the two, but you got to do one of them. All right, 28. Use the intermediate value theorem to show that f of x equals x squared plus 3x minus 6 has a 0 from 1 to 2. So once again, we are proving this guy has a 0. So the first thing I need to show is what? It's continuous. And is it continuous? Yes, because there's no holes, there's no jumps, there's no VA. So f of x is continuous, and that is going to be true for all polynomials. Polynomials are continuous because there are no holes, jumps, or VAs. All right, the next thing we need to do is figure out our y values. So what is one of the x's that I'm going to plug in? 1. All right, this is x1, this is x2. All right, when I plug 1 in here, I get 1 squared, which is 1, plus 3 times 1, which is 3, minus 6. So what's 1 plus 3 minus 6? Negative 2. All right, what's the other x value you're going to plug in? 2. So I get 2 squared plus 3 times 2, which is 6, minus 6. So what's 2 squared plus 6 minus 6? 4. All right, so these are my y values. Now, is 0 between these y values? Yes, it is. So once again, you can either write that and say 0 is between negative 2 and 4, or you can use the mathy definition, negative 2 is less than 0, which is less than 4. So yes, f of x has a 0 from 1 to 2. So notice I'm not actually figuring out what the 0 is. I'm just saying it's there. It's an existence theorem. It just gives you a way to say that it is there and it exists. So 2 things you have to show: continuous, and the point you're trying to prove is between your y values. So that's what it says up here on the poster too. F is continuous, K is between f of A and f of B, and then you can say the point exists. Are you good for IVT? Okay, so flip it over. right, this next up, these are all calculator skills. And hopefully these calculator skills are going to be just refreshers for you. That's what I'm hoping, at least. All right, I typed up the steps for how to find maximums and minimums and roots, zeros, x-intercepts, and solutions. So in this big box that has all of the words, these guys right here are just your calculator steps. All right, so you can read those, but this is the problems down here. All right, the first thing we're going to do is we're going to go into our calculator. We're going to go to y equals, and we're going to type our function in. So x to the 5th minus 6x cubed plus 9x. And we're going to hit graph. Okay, so on your calculator, you are going to find the maximums, the minimums, the increasing and decreasing intervals, and also the zeros. So when you are taking like the SAT that you took today, and things like that, Desmos is embedded into those tests. Y'all know how to use Desmos?
I was going to ask, like, if we learned how to use that in these classes.
Not really, because you have to log into the iPads. But if you want, and then also you can't have an iPad out while you're taking the test because there's no way I can put this on testing mode, which is why I don't normally do it. But when you're doing, if you want to practice using Desmos on the test, because on AP Calculus, it's also embedded into the test. So Desmos is embedded into all of these tests. You can't use it on our test in class because there's no way for me to lock down this iPad so I make sure you're not getting on other things. But when you're doing your homework, if you want to practice using Desmos, you can. You're still going to type it in. So x to the 5th minus 6x cubed plus 9x. All right, so the nice thing about Desmos is if you've used it before, is it's kind of more like a touch screen. And so you can just touch the graph where you have max and mins and the point will pop up. So when you're doing your homework, if you want to grab an iPad and use Desmos, feel free because you can just kind of touch it. You see how the point just popped up? And you can just get all the points like that, which is super cool, right? Oh no, I just lost them all. And they all stay on your screen as long as you don't touch it again. So it's kind of easier to do your increasing and your decreasing stuff. So I really do like Desmos, and I wish we had a lockdown browser for it so we could use it for the test, but we don't, which is why we use the other guys. But you can kind of see, if I'm trying to figure out what the max and the mins are, what's one of my maximums at? This one, negative 1.732. Right, where's the other one?
0.7746.
Yeah, 0.7746. Where's the minimums at? Yes, negative 0.774 and then 1.732. So those are your maximums, those are your minimums. Where would my zeros all be at? Negative 1.732, 0, and 1.732. And then if you're doing increasing and decreasing, we would say, what are you doing first? 2.
1.7.
Yep, 1.732. And then you would decrease from negative 1.732 all the way to negative 0.774. And then you would increase, and then you would decrease, and then you would increase. Does that make sense? Okay. So that's kind of how you do it with the Desmos app. Now on this calculator, because the points won't stay on this calculator, it's a good idea to sketch the graph. It doesn't have to be totally perfect. We just have to get an idea of what the graph looks like so we can write the points down and use them later. So I'm going to go second trace maximum. And And I'm going to move my little spider on the left side of my maximum. Zoom in so you can see. So move your spider on the left side of the maximum, hit enter. Move it on the right side of the maximum, hit enter. You do not want to go too far though. Just on the left and on the right. So your little hump is between these imaginary like dotted lines. And then hit enter for the guess. And then the point will pop up and you notice it's the same thing, negative 1.732. Remember, if you get the E on these calculators, that just means 0. And so then I would write that down. And then you would go second trace minimum, left side, right side, enter. And it would pop down to the minimum. And then if you notice, that was the same number as Desmos. And so I would write that down on my paper. And I would keep doing those. Now, if you're wanting to find the zeros, second trace 0. And you have to go on the left and the right side of your 0. So here, let's find this guy over here. So I'm going to find this 0. So I'm going to go on the left side of it. And I'm going to move on the right side of it. And I'm going to hit enter. And it'll pop down there. And there is my 0. So it takes a little bit more time to do it on the TI-84. And then you have to write down each one of these individual points on your paper so you have all of that to answer your questions. All right, the Desmos app just kind of lets it stay up. So when you're doing homework, if you want to practice on your Desmos app, you can. But just know for the test, I can't give you Desmos because I don't have a way to make it testing lockdown browser. All right, so let's write all that information down here. All right, so this one right here was at negative 1.732, comma 0. This guy here was at 0, 0. This one here was at negative 0.774, comma negative 4.461. This one was at 0.774, positive 4.61. And then this minimum right here was at 1.732, comma 0. All right, my graph that I sketched wasn't super accurate, but I got all those coordinate points. Okay. These two guys right here are your maximums. So I'm going to list them under maximum. So I'm going to list negative 0.774, negative 4.461, and 0.774, positive 4.461. All right, so those are coming from the two maximums. Oh, dang it, that's not a maximum. Hold on, that's a minimum. Those are maximums. Negative 1.7, shh, quit talking. 30. And then this guy here is a minimum, and this guy here is a minimum. .732, comma 0. Okay, and then for the increasing, which we kind of already talked about, we would start increasing from negative infinity all the way to this x value right here, negative 1.732. And then you would decrease from negative 1.732 all the way to this x value, negative 0.774. And then you would increase from negative 0.774 all the way to 0.774. And then you would decrease from 0.774 all the way to 1.732. And then you would increase from 1.732 all the way to infinity. All right, lots of decimals, I know. All right, now I don't have room for this, but let me pull my graph back up. Okay, so from the graph, you should be able to tell whether your zeros have even or odd multiplicity. So this 0 right here, is that going to be even or odd?
Odd.
Even.
Even. Why is it even? It bounces. What about the one at 0? Where's that one? Even or that's odd because it crosses, and then this one would be even because it bounces. Okay, does that make sense?
Yes.
All right, are we okay with the calculator stuff?
Yes.
Do I need to do any more examples or are you good? Okay, it's a lot of calculator practice. What's up?
Don't talk to my friend like this.
Oh, you would list them. So the zeros would be this guy, this guy. This guy's supposed to hit 0. So we would say negative 1.732, 0, and 1.732. And then this one was even, this one was odd, and this one was even. I kind of ran out of space. Oh, sorry, you can't see any of that. My bad. So I would list the 3 zeros. So I would just list this guy, and this guy where it hits the x-axis, and then just say even or odd. So you just have to list the x numbers.
It's crazy. Did you tell him? Yeah. So it's just like one time.
All right, if you are curious, this is what the other guys look like. I'm not going to do them because I don't want the video to last forever. We're hitting 20 minutes now. So these ones aren't as wavy when you graph them. So this second one has 2 zeros. They're both odd because they're going to cross. You would decrease from here all the way down to the minimum and increase. There is no maximum because there's no hills. And this one has 1 minimum and 1 maximum. You would decrease, increase, decrease. You would hit the x-axis 3 times. So there are 3 zeros. They're all odd though because they all cross. And so you just need to figure out what those decimals are. Use Desmos or use the calculator, but make sure you know how to use the calculator because that's how you'll have to do it on the test. Okay, so it's a lot of typing and practice with the calculator. If you notice, I have 3 decimal places, and there was a couple people on the test that still only put 2 decimal places or 1 decimal place. You will lose points, and I took a point off if you did not put 3 decimal places, even if you got the right answer. So you need 3 numbers after the decimal. Good? Okay, that's what you're going to be doing tomorrow.